All right, graphing quadratics from standard form. So standard form is ax squared plus bx plus c. Again, the a controls our scale factor, our stretch compress, our direction, okay, and c is going to be our y-intercept. So right away, just looking at the problem, we should be able to identify our y-intercept, but that's not as useful as the vertex because it's not the center. I don't know how far away it is from the vertex. So it is a key feature, but it's not very helpful when we want to graph the whole parabola. So the first thing that we have to do is we need to find the vertex. And so we're going to find the vertex by using the equation for the axis of symmetry, which is x equals negative b over 2a. Since the axis of symmetry goes through the vertex, that is our x coordinate of our vertex. And then to find the y coordinate, you simply just plug in your answer there back into the original equation to get your y coordinate. All right, so it's a little bit more work than vertex form. So our problem here is f of x equals x squared plus 2x plus 1. We want to graph that function. So we need to find the vertex. So we're going to do negative b over 2a. So in this problem, here a is 1, okay, b is 2, and c is 1. So when I plug that in, negative b over 2a, I'm going to get negative 2 over 2 times 1, which is just 2. So my vertex, my x-coordinate of my vertex is negative 1. All right. Now I need to plug that in. And so when I plug f of negative 1 in, like I'm making it on my table of values here, I know negative 1 is going to go in the middle. I plug that in, I'm going to get negative 1 squared plus 2 times negative 1 plus 1. So I do the work. Negative 1 squared is 1. 2 times negative 1 is negative 2 plus 1. When I add all that up, I get 0. So my vertex is the point negative 1, 0. Okay, so if I erase that, give myself some more space. Okay, so I know the y-intercept, okay, which was c, so the y-intercept is going to be 0, 1. And I know the vertex is going to be negative 1, 0. All right, and so now I can use the pattern, the 1 through 5 pattern again. So negative 1, 0 is right there. All right, over 1, up 1, that definitely matches with my y-intercept of 0, 1. Over 1, up 3. Over 1, up 5. And then find all the symmetrical pieces and draw your graph. All right. And again, I could have used the table values. Okay, go a couple spots smaller, couple spots larger than the vertex. Plug that in. So again, if you plugged in 0, you just get 1. Symmetrical, that one gets 1, plug in 1. I just do this work in my head real fast. So 1 plus 2 is 3, 3 plus 1 is 4. All right, and so we would match up there with our graph. All right, one more example. So here, x squared minus 6x plus 5. So right away, I know that my y-intercept is 0, 5. 1, 2, 3, 4, 5. Right, but I need to find my vertex. I'm going to use negative b over 2a. So now b is negative 6. So now the x-coordinate of my vertex is going to be 6, positive 6, okay, because negative times a negative is positive, over 2 times 1, 2. So that is 3. Now I need to put 3 in the middle of my table of values. Right, now I need to plug that in and find the y value of my vertex. So f of 3 is going to be 3 squared minus 6 times 3 plus 5. So that's 9 minus 18 plus 5 minus, Okay, so that is 9 minus 18 is -9. -9 plus 5 is -4. So my vertex is the point 3, -4. Erase that, and now I can go ahead and graph it up. So again, my vertex is 3, -4. If I use the pattern 1, 3, 5, okay, so 3, 1, 2, 3, -4, 1, 2, 3, 4, okay, over 1, up 1, over 1, up 3. All right, and now we're over 1, up 5. That brings us right to our y-intercept was. Okay, follow the property of symmetry here, and we have our graph. Again, it should be a smooth curve. Sorry for my drawing there. Okay, but yeah, it should be a nice smooth parabola there. Okay, plug in some points here. Two numbers smaller, two numbers bigger. If I plug those in, so if I plugged in 2, I'd get 4 minus 12, which is -8. -8 plus 5 is -3. Plugged in 1, I'd be 1 minus 6 is -5 plus 5 is 0. All right, so we have our graph right there.